Hello, can you hear me? David, can you hear me?
Yes, I can hear you.
Zanfar, can you hear me?
Yes, sir, I can hear you.
Mhm. Shoaib, are you there? Okay, Zanfar, what do you have? Do you know anything about Nabil?
No, sir, I have no idea. Maybe I can.
Shoaib, are you there? Can
Yes,
you
sir,
hear?
I'm here.
Yeah, okay, you can start now.
Okay, let me share the screen. I hope you can see my
Yes.
screen.
Yeah, I can see.
Okay, thank you everybody for joining and giving me the platform to speak about my project. Well, my project is called Design and Development of Laser Projector. It was done at Comsat University, Islamabad. My supervisor was Dr. Mustafa Hussain and co-supervisor was Ms. Sajja Shaukat. And let me talk about why I decided to move forward with this project basically. The need for this project arose by looking at current projector technology, which is really limited by the colors that it can produce, the surface dependency, and usually the big size of it. So we decided to basically not reinvent it because this was already present, but try to improve it by adding some RGB functionality into it, so that we can have projection onto different surfaces and stuff. This would allow us to have variable projection size. So this would allow us to project onto very small surfaces and also very large and far surfaces. Would allow us finer control over colors and pixel positions and variable environments. So the main algorithm that we used in this project is raster scanning method. And raster scanning method is, you definitely remember from the old days of CRT, how the electron beam was traversed through the screen from left to right and top to bottom. So that's what we're trying to do here. And basically what our review told us was that there was a need for mixing the beams and creating an RGB setup. And also we realized that there were a lot of outlined laser projectors, but there weren't any that would allow us to project a full picture with all of the colors. There are, but they are usually dependent on very small chip sizes using DLP and the MEMS devices. So what we tried to do was a bit on the hobbyist scale as well. So Going forward, this is our setup. As you can see, there's a green, red, and blue lasers, all incident on an X cube, and a combined beam coming out of a single surface of the X cube and incident on the X and Y mirrors of the galvanometers. So the galvanometers basically help to project the beam onto the different points on a screen or different coordinates. And this whole setup is being controlled by a microcontroller assembly, which I'll talk about later on. So the main electronics that we're using in this project is galvanometers. It has its own amplifier controller, which controls its position and allows it to have feedback control so that it can have a very precise control over its position, and its own power supply basically requirements which are needed to be met. As the brains of this operation, we are using the STM F3 Discovery. A few reasons for doing this. Basically, it allows us to have a finer control over the registers and the peripherals of the microcontroller, and it also allows us to have a development setup which can be reproduced again and again. And for modulating the laser beams, we are using MOSFETs for each of the laser. A big part of the project was trying to come up with a setup that would not limit us in our experimentation. So one of the problems that we first came by was that we did not have a very precise laser holder. The lasers that we ordered from China was basically a very unusual shape, and we were not driving direct laser diodes. So we had to come up with our own design. So we decided it CAD using this ideal holder as a reference. And it works basically on the same mechanism of tension springs, having forces applied on each of the opposite directions, so giving it a precise and a sturdy positioning. So that's what we are very proud of doing. And apart from the project itself, the other thing that we have is, I'm showing you the optical setup that we've set up. This maybe Dr. Tayeb would remember this from Comsat University. It's the same table, and we have our own posts, and there on the center we have the X cube and 3 of the laser beams. And right, so I'm going to go a bit further into it. So here's the programming part of it. Basically, what the algorithm we used was raster scanning, as I talked about, and it's nothing else than going from left to right and top to bottom. And we basically treated each of the position of the beam that it was going to jump at as a single distinct pixel. And we used to jump from that till the end, and this gave us a kind of a model that we could replicate in our software. So that's what we're doing here by having our own program in C, which would take a bitmap, and you can see the bitmap at the bottom, which is nothing else than a few pixels which are of different colors. So what it's doing is going from left to right and populating that with the required colors. But of course, for the real setup, it's a bit different because there are angles involved, and we're going to talk about that later on. And so with this simulation, we basically proved that it was possible doing something like this. And of course, if we were dealing with an electron beam, it would have been much easier, but we were dealing with a mechanical system which proved to be a little bit hard. But then we overcame that, as I'll discuss that later on. This is the basic flowchart of the program that we're using. As I said, it starts, loads the bitmap into memory, and for each grid cell from X all the way to traversing through X and traversing through Y, it checks whether it's on, and if it's on, it paints them green and red. If that is the case, if the whole grid is not finished, then it just resumes from the top. Otherwise, it just ends. So this is a simplified version, but what we did was have the control of the RGB. So it would recognize the color so that it could generate that color through the combination of the duty cycle. one of the problems that we faced with this was the slow scan speed due to CPU, and this was basically because the usual programs that run from top to bottom, and all of those checks and the usual overhead of the CPU, I felt that it proved a bit problematic. I am not sure why exactly, because as much as I have investigated it, I think the loading of the bitmap in the memory and then traversing through that took a lot of time, and then communicating that to the CPU took a bit of time. So then upon looking up into it a bit further, we realized that there was such a thing as a DMA, a direct memory access, which would allow you to have a direct connection from your memory to your peripheral. So since we were using a digital to analog converter for the galvanometers, and its analog signal, so just the voltage level would direct the laser beams position, and this was pretty lucky for us to have, because we could directly translate whatever we had in the memory to the peripheral, reducing the time. I think what we achieved with this was, without the DMA, we had like 100 hertz or 200 hertz of conversion speed for drawing the pixels, and when we used the DMA, we achieved a speed of 1 kilohertz, around about that. So that was a pretty significant bump, and it also helped us try to look into the future uses of it. And one of the other things is the limitation of the galvo with nonlinear behavior, since we are using galvos from certain manufacturers which are unnamed and basically do not patent their product, mostly because it's copied, and they do not give you any documentation so that you can get the type of behavior that it would show according to the speed and the inertia involved. And since the mirrors have a weight of its own, we had to calculate that, but none of the information was available upon asking the manufacturer. So one of the solutions for that was reducing the scan angle, and if you reduce it, it would essentially have a smaller range, but then that's not a problem at such a stage. Moving forward, this is the kind of graph that we achieved with this. This is basically a result of manually sitting through it and checking what kind of PWM duty cycle would give you what kind of power, basically. And this basically taught us a few things, that each of the lasers have its own offset. So in a production grade software or this kind of project, we basically need to calculate the offset of each of the laser and extract the quadratic equation that it would give from this each of the line, and then we can precisely map what kind of colors and power we're going to get, because power was the only measure that we had of the intensity or the luminosity of the light. So that's what we were using for now. But then later on, we are going to integrate this into the chromaticity diagram as well, but that's a topic for another day. Basically, here is the initial testing of it. I hope I have the time. I hope I'm not over the time. Anyway,
Okay.
So here I am
It's okay,
showing
Shoaib, you can keep continuing.
Thank you, sir. So here I'm showing how giving it a sine wave would move the laser beam across a certain range, and we basically calculated how much of a degree variance, how much of a degree variance would inflict, a change. So that's how we calculated what kind of range we could achieve with this. So right here I'm just testing it by giving it a faster sine wave. As you'll see, it will get a bit faster, and this is basically what's happening. It jumps from point to point, the individual laser beam, and this gives you the impression that there is a straight line, and this is still very slow, but if you go much further than this, then it will be even faster. I think the speed at which this happens is, I think, 10 to 15 kilohertz. So at that point, you cannot really you cannot identify each of the point distinctively. So your mind kind of tricks you into thinking that this is a straight line. In fact, these are just points moving very, very fast. These are our results, how what had happened. This is the final setup, and this is the kind of raster scanning that we have achieved. As you can see, it's going from top to bottom and right to left, as seen in the video. And basically we achieved a multicolored, multi-shaped bitmaps projecting onto the screen. We gave it a circle as well as a square to test the ability of it to try to draw it. Of course, we were limited by the size of the projection. You're not really limited to it because you can increase it to any distance you want, because it's just light that is traveling, and the resolution would be impacted, of course. But the best results that we have achieved here, we achieved, I think, a 20 by 20 centimeter of a square with very sharp colors. And in the picture, you can see a kind of glare coming out of it, which was not really present there. This is just the effect of the camera here. We had a pretty clean output. And this is basically my project. And these are the references that we used. Basically, what we have done is try to come up with this method from first principles instead of following some papers, because there was so less of it. But then later on, I found out more resources. But initially, we tried to look at CRT and study the graphics of how the computer handles the graphics and how it was done in the ancient times. And then we came up in our through our own method to this result. And then I realized, and of course, this is a lot of the stuff that we have done is available on the internet to some extent, and we have improved our design later on as well with this. So there are many future applications of this. This can be used in a very miniaturized displays. This can be used in the MEMS technology for very small mirrors, can be embedded into your glasses, your retinas, and it can even be used for secret communication. Basically, it will allow you to either limit this to close range or large range and have the effect of and have the ability to project a multicolored projection onto even curved surfaces. I have seen some applications of it in the welding and the steel industry, but they're using the outlines. But I was hoping that we could probably have this be applicable there as well. That's all for my presentation. I would welcome any questions that you have.
Thank you very much, Shoaib. Actually, in such a short time, I think your presentation, it needs a longer time to understand.
Yep, sir.
Yeah, because
Yes,
otherwise hard to understand. I mean, if you don't have a background like this. So
Yes, sir.
yeah, so one thing I would like to ask, you use the 3 lasers and then you got
Yes.
the white light output, isn't it?
Yes, sir. Yes, sir.
But why do you think in this way?
Well, sir, I do not know whether there is a laser that could produce a multicolored thing, because it is a combination of RGB essentially. So what we did was try to have 3 lasers, and we experimented with it to project, each of their lights at full intensity, and we saw how it got combined. And we basically got the results of a combined laser beam. So that's what served our purpose. Other than this, we could not foresee any other options in this matter.
Yeah, there are some, but anyway. So all these 3 lasers were having the same power, isn't it?
No, sir. They had different powers, but each of them had the highest power that it could and highest saturation level. So as I showed in the graph earlier, each of the lasers had a different curve. So as you see, the power for the yeah. So also this affected the visibility of it. The blue had the highest level of visibility, and then the red had the lowest. And we could not increase that because we tried some other lasers. We just could not find a laser that would give us an equal amount of visibility or luminosity. So that was kind of a limitation for us.
But you didn't take the spectrum, the white light spectrum?
I did take that, I think. I took that, and it was basically a superposition of all the three wavelengths. Yes.
How broad it was?
I think it was, I don't even remember the exact figure because we talked about this with our supervisor, and the blue, the green one was the shortest, and then the blue one was a bit more wider. But I don't remember the exact figure right now because it was a long time ago.
And this STM32F3, what exactly it is?
Sir, it's a microcontroller on a development board, so
Okay.
it gives you the access of programming it through your computer, letting you use the STM32 Cube IDE to
Okay.
let you use their hardware abstraction layer, which gives you the ability to not write the register level code, but still interface with the peripherals directly instead of having a framework like Arduino, things like that, because that takes a lot of time for it to compute because it has a lot of checks.
Okay.
And having worked with Arduino for a long time, I realized that doing it directly would be a smarter move. And of course, if we had done this with Arduino, we would not have been able to work with the DMA, which was very important for this project.
Okay. And the programming was in, what was the programming language or whatever?
The programming was in C, pure C.
Pure C.
Yep.
Actually, I have to go through your that thesis. I started, but I
Yes.
couldn't. Then after that, maybe I could have much more questions. And
Yes, sure.
you didn't try to, try to convert this one, your BS project, a little bit in to publishable way or something like this.
No, sir, I haven't had the time. Just after the university, I got recruited into a job, and then I did that for a while, for a few months, and then I just came here to the UAE. I haven't had the time, but I am thinking about it. I'm working on it on the side to try to create a product that would be reproducible.
Okay. Okay, so other people, Zanfar? Zanfar?
Yes.
Yes, you should have a question. Your project was also.
Sir, the follow-up question which you asked from.
I cannot hear you. You are from far or what exactly?
Okay, I using my earbuds. I think I will put to.
No. Remove that one and talk directly, or use the cable type headphone.
Sir, can you hear
Yes,
me now?
yes.
Clearly?
Very well. And show your face as well.
Okay. Sir, the question you asked from to Shoaib was why have you take the spectrum? I worked these diode lasers, especially green, for the photo reflectance when I was doing my working with the Dr. Mustafa. So there is also, I think the lamp, excimer lamp is showing in this setup behind which Shoaib has worked. So firstly, the spectrum. I don't think they have the facility. Yeah, they have the detector to measure the spectrum because these diode lasers have the high intense beam. They have the spectrum, they have the detector, but they have the some threshold. If they cross, they maybe damage their spectrum. So
Okay.
Yes,
I
actually, yep.
Okay, sure.
Yep. I actually know what you're talking about. The spectrometer that we have is a USB 2000. It's from Ocean Optics, and it's basically a cascading array of basically a sensor that would allow you to measure each of the wavelength, and it gives very good results. And that's the kind of results we use to obtain the wavelengths, because at first we were trying to go to the method of do the method of chromaticity diagram, which needed the wavelength, but then later on we shifted to this, and then the laser spectrum was not really needed, but it gave us very good results. And the trick for achieving a good result for with the spectrometer without changing the wavelength is to use a neutral density filter, and that would reduce the intensity, but it would it would keep intact the wavelength. And we also used basically a small uh, aperture to allow very little light to go there. But his concern is right that it would damage it. But luckily, we have not yet.
No, actually, it's not. If you use the ND filter, I mean, it's not going to damage anything. Anyway, Shoaib, I mean, what do you think? I mean, what else can be done with this project?
Oh, sir, there is a lot of things that can be done. First, we can try to use kind of galvanometers that are documented, and that would allow us to have some kind of variables and kind of data that we can work with to better model the system, so that we can expect what kind of change. Because in this system, we basically noticed that if you push the mirror too till the end and too fast, of course the inertia increases, and that produced a kind of noise, but we didn't really know what kind of speed it actually did that at. And having the ability to use its whole speed, we would need a kind of a documented galvanometers. We can also have very good lasers that would give us a very precise value. In these lasers, we noticed that there was a bit of unexpected behavior, partly because we were not using the diode laser directly, and there was a circuitry in between. And when we looked inside it, of course, there was a current limiting circuitry. And if we had used a diode driver, then probably we would not have this. Basically, we can transfer this into MEMS and have each of the mirrors be embedded into a surface, and we can make any surface basically projectable. So there is a lot of scope in it. Even in like gaming, entertainment, we can have theaters. We can also have gaming goggles, and even many things.
Okay, so if you want, you can continue this project further.
Yes. I was hoping to continue this in the coming time, but
In the
an
university or where?
opportunity, on my own,
Okay.
basically on the side, but also in the university, if an opportunity arises. I talked to Dr. Mushtaba about it, and we were hoping to try to continue this, inshallah.
Whose idea was? I mean, it's your idea or
No,
Mustafa?
this was Dr. Mushtaba, sir. Dr. Mushtaba was
And your
had worked on this
co-advisor
a
is
lot.
also. I mean, it's in the ComSet. Or?
The co-supervisor was also from ComSets, but she had helped me with the documentation.
Okay.
But the idea was solely of Dr. Mushtaba.
Okay. Okay. So David and Mudassar, if you have any question, please.
No, only about the recommendation that if someday the project is going to be shared, you maybe can use a Git software for control version. There is a page in GitHub, and you can upload the code about the project.
Yes, thank you for the question. I have already been trying to document this, and one of the the things with this project is that this was a massive success, even internationally and locally as well. This project was awarded the first position in the university, and also published on Hackaday while I was documenting it. So all of the process that I went through here is documented on Hackaday, also on my GitHub. So it was shared, and a lot of people enjoyed it. Around 3,000 people have seen it so far. You can probably see that there.
Okay, so good. So Mudassar, do you have any question?
No, sir.
Mhm. Okay, so thank you very much, Shoaib.
Thank you, sir.
Thanks a lot. We may
Thank you,
discuss
sir.
more. I mean, later after I go through your pieces. Yeah.
Okay, sir.
Yeah. Okay, David. So you can continue now.
Can you hear me? Okay.
Yes. Yes.
Okay. Mm. Okay, in the last meeting, I'm going to try to follow in the tutorial about the diffraction graded in CMAX. I maybe try to get this pattern or this another pattern. So I follow the tutorial, and then I can accomplish the results of the tutorial. And this is the pattern of the diffraction grading. This is a normal pattern for current irradiance. And this is the values of the table. We have the source, diffraction graded, and a detector. In this case, the detector is 12 by 12 and 50 by 50 pixels. And another type of diffraction grading that I did was a quadratic aperture. In this case, you can define the square UDA data. I mean, you can define the size of the quadratic aperture that you're going to use for the diffraction grading. And then when you do, you can see this in the 3D layout. That is that have the form that you previously defined. And then when you have the rays, even you can see a little dispersion in the rays. And then we in the detector viewer, we configure for log -5. Log -5 give you the opportunity to the less intense orders to manifest. And in this case, we have this pattern of the current irradiance. That is the typical pattern of the quadratic aperture. For the future work, I'm going to try to do this configuration. And this is going to be for the LIDAR. That is the work that I'm working on it.
Okay, so David, I mean, if you can make a proper the presentation, maybe we can understand more. It's bits and pieces, which if you can make a proper presentation next time, maybe we can understand. So also, I mean, on Mudassar can comment on this kind of things. Mudassar is there?
Yes, sir.
Yeah.
It seems okay, but just as I said earlier, just let me know the thing you're trying to achieve, how you will implement on in the LiDAR system, because I did not get the LiDAR system layout or something that you want to design and simulate with the ZMAX. Once I can get this, then I will see why we need this kind of you can say radiance on the detector which you are trying to achieve, or we can see how we can achieve it in a more simple way, but we will see that. But still it is a good one, especially the pattern. It's like a two-dimensional diffraction grating pattern.
Which one?
It's look
Which
fine.
pattern?
The plus kind of thing, it's
Yeah,
like
this one.
yeah, this one is really
Yeah,
good.
that is why I'm saying, I mean, if you David, if you can make a proper presentation, maybe we can understand more.
Yeah.
Okay.
In this way, you just collected some bits and pieces or something like that.
But it's good. The result seems fine, but we will see once you prepare the result, sorry, presentation, and tell us what you are doing and what you want to get at the end with the LiDAR system, then we can move forward along with you. But yeah, it was a good thing which you have just did.
Okay, so thank you very much, David. Thanks a lot.
Yeah.
Okay, Gazanfar, show your face and say something.
Yes, sir.
Open the camera. Yeah. Why you keep it, I mean, off all the time? You are one of the unique
Sir,
from Sindh, so people want to see. Yeah.
no, sir, there is net problem. That's why.
It's always in Pakistan, I mean, except in Lums, I mean, other ways everywhere. Okay, so yeah, so go ahead. What did you do?
Sir, I read the literature about the lock-in amplifier, uh, how we can proceed the article. So I didn't done any simulation because of my laptop problem. So maybe
Again
the
problem?
yeah, I told you, sir, the
Wi-Fi.
laptop Wi-Fi, yes. So he told me he going to replace the laptop, but due to the vacations in the Pakistan, so the shipment was delayed. Maybe on Monday or Tuesday I will receive my laptop. So
Mhm. So you
yes,
didn't do anything.
so no, I studied the literature, how we can proceed now forward as we done amplification and band pass filters, all these things on the multisim. So I study the how we can proceed and how we can get the result for the publication. So one thing which I studied and learned is the problem which I already mentioned was how we can detect the noise signal to noise ratio. So I worked on it. So there is some the amplifier we are actually using. They have the some noise ratio which is given in the data sheet. So the amplifier, the op-amp we use the data sheet from where we can um, doing some mathematics and we can get the result and we can get the signal noise ratio which is already mentioned in the article which we are following.
Mhm. So you are expecting to get this thing?
Yes, sure.
Sure.
Sir, I will try. Hopefully we will get these
Yeah.
things.
Yeah, but because I was expecting to finish this thing and you to start the major project.
One thing is that what we have done up till now, we have tried 3 circuit with the 2 times amplification, 10 times, and then it goes to the 100 times. So I thought it would be a better if we can make a single circuit, single amplifier circuit, which just has a variety to amplify the signal according to our requirement. Like we have some circuit in which we can vary the potentiometer or something, and its amplification vary from 0 to any limit like 100. So it will be much better. Other than that, we are taking different circuits for different application factor. We can think of
Yes,
that
sir.
if that is possible.
Mudassir, let me comment, sir, if you allow me.
Yes, yes.
Mudassir, the component we made on the multi-sim, we have to integrate them. Then we get the amplification. These just for our simplicity, whether these circuit work or not. So because the article mentioned no resistance and anything. The purpose of making the individual circuit is just to get the desired results. So in last when we will do the phase detection, then we have to integrate these all circuit in one circuit, the all components.
Tie up the circuit
Yeah.
used for 2 time amplification and then 10 time and then 100 time in a series, like you say.
Yes, yes, yes.
But as I said, like can we have something that we can do, like we didn't need to merge these cycle, we just values this sorry, adjust the values of different things, and we get the amplification factor from 0 to 200 by a single circuit, unless we combine three. So can that be
It's
possible? Because I don't know that, but I'm asking for a glance.
this is the requirement. This is how we can get the signal noise ratio, signal noise ratio. This is the compulsory. This is the required. This is some documentation I read. The website which making these local amplifiers. So they have these pre-amplifier and band pass filter, and then the instrumental amplifier. This is the basic requirement.
Mhm.
No,
Yes.
no, no, I understand that. I just say that we are taking 3 different circuit, like 200 and something like that. But I'm saying if we can at the end or whatever we combine, we get one circuit which we don't need to take a 2-time cycle and then 100-time cycle circuit and 10 times. We just take a single circuit in which we can just simply vary the resistance and capacitance value, and we get from some minimum amplification factor to a maximum one with the single circuit, unless if it is necessary to combine these one in a series. So I'm just saying that thing, not anything else.
You mean after integration?
Yeah, integration. If we
Yeah.
have to integrate,
Yeah.
we should apply one circuit, and in place of combining these three in series, can we take a single circuit which consists of 1 or 2 amplifier or maybe 3 amplifier, in which we can just vary the values of resistance and capacitance and get the amplification factor increase or decrease. That's what I'm saying.
So, Zanfar, so he's saying after integrating all the circuits.
So I think Mudassir was making that we will make the one circuit, not the two. First, we have to make the pre-amplifier circuit, which gives the 2% gain, then the band pass filter, then the instrumental amplifier, which gives us the 100-time amplification. So the Mudassir was making point was that we have to make only one circuit instead
No.
of these three circuits.
No, I think he meant to integrate now. I don't know, Mudassir.
I want to say if we want to integrate it, that's okay. But what I am saying that with every whatever the pre-amplifier or whatever the circuits we are combining, we are just getting the signal get amplified from all three of them. So if we interface them in a series, like for first one will be give us 2x, then we other 10x and other will be 100x. I am saying in place of combining these three, can we make only one simple like if we combine these three circuits, we will have around 5 to 6 amplifiers. Can we make a single circuit in which we can vary the amplification factor from 0 to 100? Like in this one, we are getting 2x, then 10x, then 100. We get same thing, but you can say a variable amplification circuit. You can say simply in simple way.
Maybe we can try.
I don't think it's possible in this way.
Yeah, just that's what I'm just saying. I don't know whether it is possible or not. I'm just clarifying for myself. I don't know that.
The main problem of the amplifier, which we are getting 22 times, is the band pass filter. If this band pass filter is not in the circuit, then we can make one circuit. So
Okay.
you don't. Yes, maybe we can. I am not expert in electronics. Maybe there's possibility.
Okay, we will see. We at the end when we finalize, we will integrate them, because that different one by one circuit is in an article. We can say it's not like good. If we make a one circuit and then we say from this output or this node we getting 2x, then this portion is band pass amplifier and we getting this much amplification factor, that will be better instead of getting putting them in the pieces in the article, especially. That's what I'm saying.
Okay, so Zanfar, when you, when you start your stuff and when whatever you achieve after that, you can think what Mudassir is saying. Okay?
Yeah.
So,
I am combining the three circuit. I'm working on it, but I just want to ask him that if he had anything in that. So let's see when I combine them what I get. I don't know yet what will happen.
I think we this is not possible. I don't comment on this because I'm not expert in electronics. Because the main we are want to get the signal which is buried in the noise. So yes, the first amplifier is which is 2-time is just to amplify the input signal. The band pass is then just passes the signal which we required, which is around I think 10 hertz. Oh, sorry, 100 kilohertz. I think. So then the amplification, then the last amplifier, which is instrumental amplifier, which amplify our signal to the 100 times, is just it's amplify the noise and the signal. So that's why.
Okay, so yeah, Zanfar, if you can make 2-3 slides, maybe next time, show in a block diagram, okay, the block diagrams of the parts, and then the circuits, whatever you have. Maybe we can understand more. Yes?
Sure.
Yeah, 2-3 slides, and probably in this way we can understand more. Otherwise, I feel like I'm just in the air. So thank you very much, Zanfar. And David, everything related to the Shoaib, I mean, if you go to the page of virtual laser group, you can find all the things. So please keep visiting the page. Nobody visit it, and there are a lot of information on it, and about the Shoaib and about each and every member, except Mudassar. So David, you can find everything about the Shoaib. So I think Nabil is not here. So I don't know. Shoaib, I mean, I will go through your stuff, and I need your expertise in many other things, but I have to check out.
Yes, I do a quick
Sure.
search in the page. I see that they have many things in common, Shoaib and me, because they are the profile is about electronics and computing and programming, have some
Yeah, I mean,
similarities. Okay.
yeah, yes, definitely he has. But the thing is that I don't need only electronics kind of stuff. I need some other things as well. So anyway, I mean, he has a very good profile, and probably he can be very useful for some other things.
Sure, sir.
Yeah. So, but we will discuss. I mean, this was just an introduction kind of thing. And so, if any of you, I mean, want to say anything, please go ahead.
I just want to ask, I don't know, did you have any discussion with Dr. Fayaz?
No, he sent the message there. I mean, he didn't read in the group. He said he will not come today, this meeting.
Okay, I don't know because I'm waiting for his response about the thing I just sent him. So I did not do anything further because he didn't comment on that or did not give me an answer, any answer.
Uh,
I'm
uh,
not sure.
I told you, I mean, he may give the answer, but he may not give very quickly. But
That's why I
you
did
can
not,
you
I
can
did not.
ask, you can privately send him message. I mean, if I can reply to you or something like this.
Okay, I will because I didn't start the work on sequential mode because of that. Because once he decided, okay, this is the thing we want, so then I can try in a sequential mode, which has a less chance, but still we can try it. I'm just waiting for his response.
He was supposed to send us something that the manuscript or something, isn't it?
Yeah, manuscript and then the
But he
replacement we
didn't.
want for the waveguide.
But he didn't, huh?
Yeah, he didn't give any
So
answer for the stuff I
yeah,
have sent him.
yeah. I mean, so we don't know what kind of. I mean, that will be collaboration. I don't know.
Okay, I will.
Yeah, you
talk.
can discuss privately. I mean, if you want. with him.
Okay, I will just send him a message.
Yeah. So thank you very much, all of you. And it was nice meeting, short. And probably in the next meeting, David to organize his presentation, and Zanfar to make 2-3 slides of his project. And important thing about the ultra fast laser, I think you have to jump in. Yes, Zanfar. And Mudassar, I don't know. Mudassar, maybe discuss with the Fiaz Sahib or whatever it is. So, and one of the thing that Nabil, I have given him some tasks. So probably he's on Stiptan's father was died, so probably he went there or something like this.
Oh,
So
okay, we will see.
yeah. So, but it was yesterday. It was day before yesterday or yesterday, I don't remember. So it was kind of Quran Khwani today or something like this. I asked him, I delayed the meeting because of this. He too, but even in this case, his style is like this.
He's like that.
Yes.
You know him. You know him better.
Yeah, but I need him. So that is why some people I need. So I have in Urdu we call के वो नखरे उठाने पड़ते हैं. हाँ, और एक और भी है कि हुसन जब आता है तो फिर नज़ाकत भी आ जाती है. That's what is going on here. Yeah.
You
Yeah.
can say that.
Yes.
But he is from the beginning. He is like
No,
that.
one actually one
I
thing
do
is
the
for
same.
you, one thing is for him.
I know.
And
I know that, but
Gazanfar is bit neutral because Gazanfar I want to take him to the other side.
no,
Let's see.
Gazanfar is like little bit. You can say in a safe hand. I am little bit stuck with the thing, so I have to carry that as
Yeah.
well.
Okay. Yeah. Anyway, Gazanfar. So, few words about the ultra fast. What is your plan?
Sir, I'm working on the ultra fast laser. So I study all the basics about the ultra fast laser. Still, there are some confusion which may be solved
Yeah.
by your lectures,
Yes, by
following your
lectures.
lectures.
But the thing is that lecture will go slowly because most of the students they don't even have basic laser knowledge. Okay, so you can discuss
Yes.
with me privately. Okay,
Oh,
we can come online, have a meeting, and we can discuss privately. That because I may need in the future for each and every candidate to have a private meetings. In the group meeting, sometimes you cannot discuss all the things. So in this way, you can arrange. You can mention that what do you want to discuss, and we can discuss. Okay,
sure.
and you have to install the lab view and lab 2. Okay,
Sir,
at least do this one.
yes, I installed the review in my laptop, so and also the multi-sim, all the software are working very well. Also, the I following the video you shared with me. Also, I think it's lab 2. I download all these files, and also I opened these files. So,
Mhm.
but didn't understand anything.
Yes, you cannot actually understand until you understand the ultra fast laser, because that lab 2 integration in the lab view actually you cannot understand at all. What is a compressor, and what is the meaning of compressor, and what kind of compressor, what kind of stretchers, or something like this. Anyway, we can have a
Yes.
private meeting and we can discuss there. And the course will definitely go, and you have to take that course definitely. I don't know how many people will be at the moment is 20 or 22, something like this. And it will help you, but it will go very slowly. Okay, Zanfar? So, okay then, see you in the next meeting. And let's see, I mean, Zanfar and the Beal must be, I mean, I want him to conclude some of his work. And David also. And to Mudassar, I don't say anything. I'm afraid of Mudassar. So, because when the person
No,
are when the person are senior, then it's very difficult. Okay.
No, I'm waiting for
I'm
other
just kidding.
person responses basically.
Okay. I'm just kidding. Okay, then time is gonna finish, so we will meet in the next meeting. Thank you very much, all
Yes,
of
sir.
you.
Thank you, sir. Thank you, sir. Goodbye.
You have 1 minute, sir.
Thank you.
Yes. Say.
I want to.
Say.
Okay, when everybody leaves, then I have to discuss something with
Okay.
you.
Okay, then
Yes.
other person to leave, and he wants something.
Okay, sir. Allah Hafiz.
Allah Hafiz, Allah.
हाफिज अच्छा सर वो मैंने ये कहना था वो जो ऑप्टिक्स कॉन्टिनेम वाले हैं वो नबील ने मेल की है उनको
आज मैंने उसको कहना था ना, मैं उसको फोन करके कहता हूँ.
मैंने अभी क्योंकि मैंने उसको फॉलो अप कर रहा हूँ वो 5 हफ्ते से ऊपर हो गया अदरवाइज वो इतना टाइम नहीं लेते
नहीं,
नहीं
वो
मसला क्या है
उन्होंने रिव्यूअर्स को भेज दिया हुआ है.
वो तो बहुत टाइम से गया हुआ है लेकिन जब मैंने वो पहले कराए थे 2
हाँ.
पर वही उसमें वो आता था कि हाँ जी रिव्यूअर 1 को रिक्वेस्ट गई है तो आगे स्टेटस आ रहा होता था कि रिक्वेस्ट पेंडिंग है क्या है वो नहीं आ रहा उसमें तो मैं थोड़ा सा पता नहीं
उसको कहता हूँ
हूँ
नहीं, पता क्या मसला है आजकल सारे जर्नल जो है ना वो लेट हो रहे हैं. किस लिए? कि यूरोप पूरे में जो लोग हैं ना ये समर में वेकेशन पे चले जाते हैं 2-3 हफ्ते अगस्त में, इसलिए वो लेट हो रहा है. लेकिन बहरहाल मैं उसको कहता हूँ मेल करें.
मैंने खुद भी मेल की थी लेकिन मुझे कोई रिस्पांस नहीं आया तो मैंने कहा चलो देखते हैं क्या करते हैं.
और रिस्पांस इसलिए भी नहीं आ रहा ना कि वो ऑन द डेस्क है ही नहीं, मौजूद ही नहीं है.
हाँ वो मुझे भी यही लगा लेकिन मैं काफी टाइम ले गए ये लोग इसलिए मैं चलो देखते हैं उसको कैसे क्या
इन दिनों जब भी सबमिट किया जाता है ना समर के दिनों में वो लंबा टाइम ले लेते हैं.
चलें देखें, फिर तो देख सकते हैं, फिर कोई मसला नहीं है, देखते हैं क्या होता है।
ठीक है फिर। ओके
ठीक है,
ओके
ओके, हाफिज़।